All right, now that you guys understand how to factor if you have a trinomial that starts with x squared, we also have to look at what happens if you have a trinomial that starts with an x squared but has a coefficient of something other than 1. So if I look at this multiplication problem I've put up, I realize that when I multiply two binomials, I still get that trinomial that I've already seen, but now I see that if I have one of my binomials having starting with a term that has x with a coefficient other than 1, so like for example the 3x here, that's when I notice that I am now getting that first term, that x squared term or quadratic term that doesn't start with a 1. So it may be a situation where one of my binomials starts with something other than just x, or it may be a situation where both of them do. So we're no longer going to be able to use factor sum tables and just simply put an x in the front of each. Now we're going to have to do a little bit more complicated method that requires some more work on our part. We're going to have to use factor sum tables and factoring by grouping. So here are going to be my instructions here. I'm going to factor, I'm still going to do a factor sum table, but now instead of doing factors of just the last, I'm going to do factors of the first times the last. Like before, I'm still going to have a sum of the middle, and my table is going to be solely for doing some trial and error. So let's go ahead and look at this example. So first thing I'm going to do is I'm going to make my factor table. And it's going to be the first times the last, and I'm going to do my sum. So I want factors of first times last, so I'm going to have factors of 15, and I'm going to have a sum of negative 16. So this is my place for trial and error. So maybe I first try 3 times 5. However, 3 plus 5 does not equal 16. I also realize that two positives are never going to add to be a negative. But if I had two negatives would multiply to be a positive. So maybe I try negative 15 times negative 1. That equals positive 15, and negative 15 plus negative 1 does equal negative 16. So now I'm going to go ahead and I'm going to use that to break up my middle term. So the 3x squared is going to be the same. The plus 5 is going to be the same. However, now in the middle, I'm going to have a minus 15x and a minus 1x. So now according to factoring by grouping, I'm going to go ahead and I'm going to group my first two and my last two and put a plus sign in between. And I see that my first two have a GCF of 3x, so I take that 3x out, leaving me with x minus 5. My plus sign drops down. Negative 1x and plus 5, I want it to look like x subtract 5. So I'm going to go ahead and take out a negative 1 and be left with x minus 5. From here, I realize that my two terms have an x minus 5 in common. So I'm going to take that x minus 5 out. I'm going to multiply it by 3x and then plus a negative 1, which is just minus 1, and there's my factored form. So again, a slightly longer method than what we've learned before. Let's look at, I think I have 2 more examples total, so let's look at the next one, and then the third one would be a good one for you to try. So first thing, like normal, I check for a GCF. I don't have one. So now I'm going to go ahead and I'm going to do factors of the first times the last. So 4 times negative 15 is negative 60 with a sum of the middle still. So this is my area to do some guessing and checking. So I'm fairly quick at it, so I won't use a ton of time for guessing and checking. I could use my calculator to assist me, so let me demonstrate what I would do if I didn't know a lot of factors of 60. I would say, well, it's divisible by 2, so I know that one of them has to be negative. So maybe I do negative 2 times 30. That does not equal negative 4. And I'd say, can I divide 60 by 3? Yep, you bet. So negative 3 times 20 does not equal negative 4. Then I could do 60 divided by 4 with my calculator, and I get negative 4 times 15. So none of those are working, so then I can try dividing it by 5, so on and so on. What I will realize as I continue checking is that I can say that negative 6 times 10 is negative 60. However, negative 6 plus 10 is positive 4. Since my sign is the only thing that's wrong, I'm going to go ahead and I'm going to flip them and say negative 6 times, or excuse me, 6 times negative 10 and 6 plus negative 10. And I do get negative 4. So now that I found that, remember that's not going to be my answer. I'm going to use that to leave my first term alone, leave my last term alone, and use that I just found to break up my middle term. So my middle term now becomes plus 6x minus 10x. Now I'll do factor by grouping, and I'll group my first two and my last two. I'll put a plus sign in the middle. 4x squared and 6x have a GCF of 2x, giving me 2x plus 3 plus negative 10x and negative 15. I want it to be 2x plus 3, so I'm going to go ahead and take out a negative 5 instead of just a 5. And negative 10 divided by negative 5 is 2x. Negative 15 divided by negative 5 is plus 3. I now notice that I have a 2x plus 3 I can pull out to the front. When I do, I'm left with a 2x plus a negative 5, which is just 2x minus 5. And I now have successfully factored into a multiplication problem. All right, one last example. Like I said, this would be a great one for you to go ahead and try. All right, now that you've had a chance to try one, I'm going to go ahead and start by doing factors of 6 times 35. So I get factors of 210 and a sum of negative 31. Another drawback to these types of problems is that the numbers I get can be really big. So I'm going to go ahead and use my calculator to do some guessing and checking. One thing I do realize is that I'm going to have two negatives, because otherwise, if I have two positives, I'm never going to add to be negative. If I have one positive and one negative, I'm never going to multiply to be positive. Therefore, I have to have two negative numbers. So I'm going to go ahead and pause my video. I'm going to write out my list of factors, and then I'm just going to kind of describe what I did with my calculator to find this answer. So I used my calculator to just say, is 210 divided by 2? Yep, it's 2 times 105. However, they do not add to be negative 31. Is 210 divisible by 3? Yep, it's 3 times 70. However, they do not multiply to be, or excuse me, add to be negative 31. Is it divisible by 4? Nope. Is it divisible by 5? Yep, don't add right. Is it divisible by 6? Yep, doesn't add right. Is it divisible by 7? Yep, doesn't add right. Is it divisible by 8? Nope. 9? Nope. 10? Yep, and that adds right. So there's what I'm going to choose right there. Again, remember that means that because it's just 6x squared as opposed to just x squared, I leave the first term, I leave the last term. I use this table to break up my middle term, giving me minus 10x minus 21x. So I'm breaking up that negative 31x. I'm now going to go ahead and group my first two and then group my last two. I'm going to put a plus sign in between. My first two I see I can take out a 2x, leaving me with 3x minus 5. I'm going to go ahead and take out a negative for my second two since I see I'm going to want a negative there. So I can take a negative 7 out, leaving me with 3x minus 5. I now have a 3x minus 5 in common that I can pull out to the front. And I'm left with 2x minus 7. And again, I'm factoring, therefore my goal is to get a multiplication problem, which I have successfully done. So big thing to remember is it's no longer just factors of the last, but factors of the first times the last. The sum is still of the middle, and I'm going to use my answer to break up my middle term. One thing I see students do a lot is once they learn this method, they forget that if they are given something like this, let's say minus 5x plus 6, that this I can just use the shortcut method, just the factor sum tables, without the work of breaking up the middle. So please be careful that you are checking that you use this method only if you have a coefficient that's not 1 in front of the x squared.